Hello everyone and welcome to today's video where we dive into another powerful feature introduced in C++20, consteval. This is a keyword that might look simple, but it has deep implications for compile-time programming in C++. In this video we will explore what consteval means, how it differs from constexpr, and how you can use it effectively in your own code. Let's start by understanding the motivation behind it. In C++, we've had constexpr since C++11. It allows us to evaluate functions at compile time if possible. That's the key phrase. If possible. But what if you want to enforce that a function must be evaluated at compile time? That's exactly where consteval comes in. When you mark a function with consteval, you are telling the compiler that this function must be evaluated at compile time. No exceptions. If you try to call it in a context where compile time evaluation is not possible, the compiler will throw an error. Let's look at a simple example. This function is now guaranteed to run at compile time if you try to call it like this. This works because the argument 5 is a constant and the result can be computed at compile time. But if you try this, the code will not compile. The compiler will complain because getValue is not a constant expression, and consteval requires that all its inputs and outputs are fully known at compile time. Let's think step by step about what this means for you as a developer. Consteval gives you a guaranteed compile time evaluation. This is extremely useful in scenarios like metaprogramming, compile time validation, and generating lookup tables or other data structures that should not have any runtime overhead. Now let's compare it to constexpr, because this is where a lot of confusion happens. A constexpr function can be evaluated at compile time if given constant inputs. A consteval function must be evaluated at compile time, or your code won't compile. You might use constexpr when you want flexibility. Maybe sometimes runtime is fine, and other times compile time is better. But you'd use consteval when runtime calls are simply unacceptable. Here is an example where consteval helps enforce constraints. This is useful for library authors and developers working on embedded systems or performance-critical applications. It ensures that invalid inputs are caught at compile time, not at runtime when it might be too late. Another thing to note is that consteval functions cannot have any side effects. You can't use them to write to output streams or modify global state. That's because they are part of the compile time world, and everything must be pure and deterministic. Let's see how you might use it in practice. This is a classic case of metaprogramming, but it's much clearer and safer using consteval. To wrap up, consteval gives you precise control over compile time logic. It's stricter than constexpr, but that strictness can be exactly what you need when writing safe and efficient code. That's all for today's video. I hope this helped clarify what consteval does and how to use it. If you learned something new, feel free to like, subscribe, check out the playlist on the screen, and I will see you in the next one.